Welcome to your deep dive on the Internet of Things. We got your notes and chapters from that IoT textbook you've been going through. You're clearly looking for more than just the buzzwords.
Yeah.
You want the real deal, how this tech works, what it can do,
Absolutely.
and even like the potential headaches it brings.
Right on. What's fascinating is that IoT is practically woven into our lives these days,
Yeah.
from our smart homes and factories to healthcare.
Everywhere.
This deep dive should give you a solid understanding of the core concepts, the protocols,
Mm-hmm.
and how it all links up with the cloud.
Okay, I'm ready to jump in.
Yeah.
So I see chapters on sensors, microcontrollers, protocols,
Yeah.
even cloud and fog computing.
Lots to unpack.
Lots to unpack here. Instead of just defining the Internet of Things, which I know you already have a good handle on,
Right.
let's start with a question that popped into my head while I was prepping.
Okay.
What's the one thing about IoT that most people don't realize?
That's a good one. I think a lot of people miss how much intelligence is actually happening at the edge
Mm-hmm.
in these devices.
Okay.
It's not just about like dumb sensors sending data to the cloud.
Right.
These things are making decisions on their own, responding to changes in real time. Imagine a security camera that adjusts its settings based on the time of day,
Oh, okay.
or a smart thermostat that learns your heating and cooling preferences. That's intelligence built right in.
So it's like they're developing their own little personalities almost.
Exactly.
Okay, that makes the whole Internet of Things name make a lot more sense.
Yeah.
It really is about like things making choices, not just blindly following instructions.
Exactly. And that's where things get really interesting, because with that intelligence comes the ability to adapt and respond to situations we can't even anticipate
Right?
when we're designing these systems.
Wow.
It's like giving them a set of rules, but also the freedom to bend them a little when needed.
But that also sounds like a recipe for chaos. I mean,
Mhm.
more intelligence also means more potential for things to go wrong, right?
Yes.
What are some of the big challenges that come with this level of device intelligence?
You're hitting a crucial point.
Mm-hmm.
One of the biggest hurdles is security. If these devices are making their own decisions, we need to be extra careful about preventing misuse. Imagine someone hacking into your smart home and taking control of your appliances. That's a nightmare scenario.
Okay, yeah. I'm getting chills just thinking about that. So security is a big one.
Mm-hmm.
What else?
Privacy is another huge concern. Think about all the data these devices are collecting about our lives.
Yeah,
Everything from our sleep patterns to our energy consumption.
right.
Safeguarding that information is absolutely crucial. And then there's the sheer complexity of managing these intelligent systems.
Mm.
We need to ensure reliable connectivity across a range of devices, optimize power consumption for those running on batteries, and handle the massive amounts of data being generated.
It sounds like a balancing act between harnessing the power of these intelligent devices
Yeah,
and keeping them from turning against us,
right.
either intentionally or by accident.
That's a great way to put it. It's a constant challenge for developers and engineers in the IoT space. And to really grasp how we tackle this,
Mm-hmm.
we need to understand how these systems are structured. Think of it like a cake, with each layer having a specific function, the IoT stack.
Okay. I love a good cake analogy.
Right.
Walk me through the layers.
Let's take a simple example like a smart watering system.
Okay.
The bottom layer is the physical layer, where you got your soil moisture sensors doing the actual sensing.
Mm-hmm.
But those sensors are pretty dumb on their own. That's where the processing layer comes in.
Mm-hmm.
Usually in the form of a microcontroller, like a tiny brain that analyzes the data from the sensors.
So we're moving from the real world into the digital world at that point.
Exactly.
Okay.
And now we need to connect the physical sensors and that microcontroller brain.
Right.
That's the job of the hardware interface layer.
Okay.
Moving up, we have the RF layer, maybe a Wi-Fi module that transmits the data wirelessly.
Mm-hmm.
But how does it know where to send that data? That's where the session layer comes in, using protocols like MQTT to manage communication between the device and the cloud.
Okay.
And finally, you have the user experience layer, which could be a mobile app showing you real-time soil moisture levels and letting you control the watering schedule.
Mm-hmm.
And all of this together forms the application layer, the complete system for managing your plant irrigation.
So each level is like a puzzle piece. And when you fit them all together, you get this complex but incredibly powerful system.
Exactly. And this layered model is crucial for developers because it breaks down this otherwise mind-boggling complexity into manageable parts.
Right.
But not all IoT systems are created equal.
Right.
Some, like your watering system, are relatively simple.
Yeah.
Others, like those used in industrial automation, involve far more sophisticated processing and data handling.
So are we talking about levels of complexity within IoT, like levels in a video game?
That's a great analogy. Simple applications with no cloud integration might be considered level 1. As we add cloud involvement, data storage, and advanced analytics, we move up to levels 2, 3, 4, and 5.
So a level 5 IoT system would be like the boss level of IoT,
Yeah,
requiring a lot more expertise and resources to build.
you got it.
Mm-hmm.
And that brings us to the role of the cloud. Especially for these higher-level systems, the cloud is essential. It provides storage for massive amounts of data, the computing power for complex analysis, and offers cost savings by allowing systems to share resources.
So the cloud is like the brain of these larger scale IoT deployments.
In many ways, yes. It allows these systems to grow and evolve over time. But to use the cloud, our devices need a way to talk to it. That's where communication protocols come in.
Yeah.
Think of them as the languages of the IoT world, enabling all these different devices to understand each other and share
So
information.
it's like a giant digital cocktail party, and everyone needs to speak the same language to have a conversation.
Exactly. And there are a few key players in this space. We've already mentioned MQTT, which is great for efficient data transfer between devices in the cloud. But what if you have a device with very limited resources, like a tiny sensor running on a button battery?
I'm guessing there's a different protocol for that?
Yeah, bet. That's where CoAG comes in. It's designed for constrained environments using minimal resources,
Okay.
like sending a postcard instead of a bulky package.
So the choice of protocol really depends on what you're trying to achieve
Right.
and what kind of limitations you're working with.
Exactly.
But if we've got billions of devices all chatting away, how do we keep track of who's who? I remember from my notes that each device needs its own unique address.
You're right. It's just like needing an address to send a letter. In the IoT world, we use concepts like IP addresses, both IPv4 and IPv6,
Right.
to give each device a unique identifier on the network.
Yeah.
And then we have URIs, which are like street addresses, used to identify specific resources on the internet and control how they're accessed.
Okay, so addresses and identifiers are crucial for keeping the information flowing to the right places in this giant interconnected network.
Right.
But it seems like everything keeps coming back to the cloud.
Yeah.
Can you break down how cloud computing specifically supports these IoT applications?
Sure. Cloud computing provides a whole toolbox of services that are perfectly suited for the demands of IoT.
Okay.
You've got SaaS, which is like renting a pre-built software tool like your email or project management apps. Then there's PaaS, which is more like getting a set of building blocks to create your own custom applications.
So SaaS is ready to wear, and PaaS is more like bespoke tailoring.
That's a great way to put it.
Okay.
Then you have iOS, which is like renting the raw materials and building your own data center from the ground up.
Oh, wow.
It gives you the most control, but also requires the most expertise.
That's a lot of options. It sounds like there's a cloud solution for pretty much any IoT application you can dream up.
You're absolutely right. But before we get too carried away with all the shiny possibilities of the cloud, we need to talk about the potential downsides.
Okay.
What are some of the concerns that come to mind when you think about entrusting all this data to the cloud?
Well, security is definitely top of mind.
Yeah,
With all that sensitive information floating around in the cloud, it feels like a juicy target for hackers.
you're spot on. Security and privacy are absolutely paramount when it comes to cloud-based IoT systems. We need to ensure that data is encrypted, both when it's stored and when it's being transmitted. And then there's the issue of cost. Transferring huge amounts of data to and from the cloud can get expensive. Plus, you have to consider what happens if you need to switch cloud providers. Moving all that data and reconfiguring your systems is no small feat.
So it's not as simple as just throwing everything into the cloud and calling it a day.
Right.
There are real strategic decisions to be made, but we haven't really touched on this idea of fog computing yet. I'm curious how that fits into the picture, especially when we're talking about sensitive data and potential security risks.
That's a great segue. Fog computing is where things get even more interesting. Fog computing is like having these little pockets of intelligence
Okay.
spread throughout your IoT network.
Mm-hmm.
Instead of sending all the data to the cloud, we process some of it right there at the edge, closer to where it's generated.
Okay.
Think of it this way. If your smart security camera sees something suspicious in your yard, it can analyze that footage locally and decide whether to send an alert immediately instead of waiting for a round trip to the cloud.
So it's all about speed and efficiency.
That's part of it. By making decisions closer to the action, we reduce latency, which is crucial for time-sensitive applications like self-driving cars or industrial automation where even milliseconds matter. But fog computing can also enhance security.
Okay, now that's what I was getting at. Explain how.
Well, by processing data locally, we reduce the amount of sensitive information that needs to be transmitted to the cloud, which minimizes the risk of interception. It's like keeping your most valuable jewels in a safe at home instead of sending them across the country in a flimsy package.
Makes sense. So it's a more distributed and layered approach to security, which I guess aligns with that layered model of the IoT stack we talked about earlier.
Exactly. But fog computing isn't just about shifting processing power to the edge. It also allows us to create more resilient systems. Imagine a scenario where your internet connection goes down. With fog computing, your smart home devices can still communicate with each other and function locally, even without access to the cloud.
So it's like giving your IoT network a backup brain just in case the main one is unavailable. Like it. But I'm curious. We keep talking about all these complex systems and protocols. What if I just wanted to dip my toes into the world of IoT, maybe build a little project at home? What would I need to get started?
There are some fantastic platforms out there that are perfect for beginners. Arduino and Node MCU, for example, provide all the hardware and software you need to start experimenting with sensors, microcontrollers, and basic connectivity. In fact, your notes mentioned an example using Node MCU with MQTT to create a simple publish-subscribe system.
Oh, yeah, MQTT. That's that lightweight messaging protocol we talked about earlier. But I thought we were just talking about fog computing. Is MQTT still relevant in that context?
Absolutely. MQTT is very versatile and can be used in various ways within an IoT system. It's not just about sending data to the cloud. It can also be used for communication between devices within a local network, which is often a key part of fog computing. So you could use MQTT to have a sensor publish data locally to a fog node for processing. And then that node could decide whether to send a summary of that data to the cloud or take some action locally.
So it's like adding an intermediary, a local translator who can filter and summarize information before sending it on to the big boss in the cloud.
I like that analogy. With NodeMCU and MQTT, you could easily set up a system at home where a temperature sensor publishes data to a local Raspberry Pi acting as a fog node. That Pi could then analyze the data and turn on a fan if the temperature gets too high, all without involving the cloud.
Okay, that's a project I could actually wrap my head around. I'm feeling inspired to try that. But I'm also remembering we talked about another protocol, CoApp, which is specifically designed for devices with limited resources. Does that come into play in these beginner-friendly projects?
CoApp is fantastic for those situations where you have tiny devices with limited processing power and battery life. Think of it as the minimalist's choice for IoT communication. While MQTT is all about setting up persistent connections and continuous data streams, CoApp is more like sending a quick text message. Short, efficient, and to the point.
So if MQTT is like having a live video chat, Co is more like sending a quick status update.
Yeah.
I'm starting to see how these different protocols fit into different parts of the IoT ecosystem. But can you give me a concrete example of when I might choose CoFIM over MQTT for a project?
Imagine you're building a smart garden system.
Okay.
You have a soil moisture sensor that only needs to report its readings once an hour. Using CoFAP, the sensor can simply send a quick message with the moisture level when it's needed, saving precious battery life. It's like checking in with a quick text instead of having a constant video call draining your phone's battery.
Okay, that makes sense. I'm getting a feel for how these different protocols play different roles. But we touched on something earlier that I want to circle back to, the different message types within CoFIN. Can you remind me what those are and why they're important?
Absolutely. Co has 4 main message types: confirmable, non-confirmable, acknowledgement, and reset. Think of them as different ways of sending and acknowledging messages, kind of like choosing between registered mail, regular mail, and a return receipt.
Okay, walk me through those options.
A confirmable message is like sending a registered letter. You need confirmation that it's been received. If an acknowledgement isn't received within a certain time, the sender resends the message, ensuring that critical information doesn't get lost.
So it's like a safety net for important data?
Exactly. Non-confirmable messages, on the other hand, are like sending regular mail. You don't get confirmation of receipt, so they're more efficient, but less reliable. Then we have acknowledgement messages, which are simply used to confirm receipt of a confirmable message.
So they close the loop and provide that peace of mind.
You got it. And finally, reset messages are like sending a signal that something went wrong. Okay, if a message couldn't be processed correctly,
Right.
it's a way for devices to communicate errors and reset the communication flow.
It sounds like Cohap has a whole system in place to make sure the communication is reliable, even when we're dealing with devices that might be unreliable themselves.
That's exactly right. And those message types are combined with different request response modes to handle various scenarios. You can have piggybacked responses where the acknowledgement and the response are sent together, separate responses where they're sent separately, and even non-confirmable requests and responses for situations where reliability is less critical.
So it's like a whole mini language within a language designed to make sure everyone's on the same page.
That's a great way to put it. It's all about flexibility and efficiency, especially in the context of resource-constrained devices.
Okay. We've gone pretty deep on communication protocols, but there's one big topic we haven't addressed yet: security. I know you mentioned it briefly before, but with all these devices connecting and sharing data, security seems like a massive concern.
You're absolutely right. Securing an IoT ecosystem is a multifaceted challenge, but one we absolutely have to tackle head on.
Okay, so we've covered a lot of ground on how these IoT systems work, but it
Yeah.
feels like we're kind of tiptoeing around the elephant in the room: security. With billions of devices potentially vulnerable to attacks, it seems like, I don't know, like a hacker's paradise.
You're not wrong to be concerned. When everything is interconnected, a single weak point can have ripple effects across the entire network.
Yeah,
It's like a house of cards.
right.
One wrong move and the whole thing collapses.
So where do we even begin with something this complex?
Right.
Do we need to hire a team of cybersecurity ninjas to protect our smart coasters?
Well, maybe not ninjas, but a layered approach to security is essential. Think back to the IoT stack we discussed earlier. We need to consider security at each level: the software,
Hmm.
the infrastructure, the data storage,
Right.
and the network itself.
So it's like building a fortress with multiple walls of defense,
Exactly.
each one reinforcing the others.
Let's start with software. Secure coding practices are crucial.
Okay.
Developers need to write code that's resistant to common attacks, like buffer overflows and SQL injections. It's like building a house with strong foundations and reinforced walls. And just like you need to patch holes in your roof, software needs regular updates to fix vulnerabilities that hackers could exploit.
So it's an ongoing process, not a one-time fix.
Absolutely. And then we have infrastructure security.
Okay.
This is about protecting the physical devices themselves.
Right.
Think locks, cameras, and access controls to prevent tampering.
Mm-hmm.
But it's also about using firewalls and intrusion detection systems to monitor network traffic and block suspicious activity. It's like having a security guard at the gate and motion sensors inside the building.
Okay, so we're talking about both physical and digital layers of protection.
Right.
What about the data itself? How do we protect all that sensitive information these devices are collecting?
That's where storage security comes in.
Okay.
Encryption is key here.
Mm-hmm.
We need to encrypt data both when it's stored on devices and when it's being transmitted across the network. It's like putting your valuables in a locked safe before shipping them. And just like you make backup copies of important documents, we need robust data backup and recovery procedures to protect against data loss,
All right.
whether it's due to a technical malfunction or a malicious attack.
So we're talking about protecting the data at rest, in transit,
Yeah,
and having a plan B if things go wrong.
exactly.
What about network security? I'm guessing that's a whole other can of worms.
It is, but it's also one of the most crucial aspects of IoT security. We need to make sure the communication channels between devices and the cloud are secure. This involves using secure communication protocols like the MQTT and CoAP we discussed earlier, and implementing VPNs for secure remote access. It's like having a private, encrypted tunnel for your data to travel through instead of sending it out on a public postcard.
Okay, I'm starting to see the scope of this challenge. It's not just about securing individual devices, it's about securing the entire ecosystem.
Yeah.
But are there any established guidelines or best practices for IoT security? It feels like we're in uncharted territory here.
Actually, there are several organizations, like NIST and the IETF,
Okay.
that have developed frameworks and recommendations for IoT security. These documents provide a roadmap for organizations to build more secure systems,
Oh, okay.
covering everything from device design to data management to network security.
So it's not like companies are just left to figure it out on their own. There's expert guidance available.
Exactly. And there's a growing industry dedicated to IoT security, with companies developing specialized tools and technologies to address these unique challenges. Think firewalls designed specifically for IoT devices, intrusion detection systems that can spot anomalies in sensor data, and vulnerability scanners tailored to the specific protocols used in IoT networks.
That's good to know. But all this talk about security makes me wonder about the role of fog computing.
Yeah.
It seems like processing data closer to the edge could potentially enhance security, but I'm not entirely clear on how.
You're right. Fog computing can play a significant role in security. By processing data locally, we reduce the amount of sensitive information that needs to be sent to the cloud, minimizing the risk of interception. It's like having a security checkpoint at the entrance to your neighborhood instead of relying solely on the security at the city limits.
So it's like a distributed security model, spreading the responsibility across the network.
Exactly. And fog nodes can act as little security guards, performing tasks like intrusion detection and access control right there at the edge. They can filter out malicious traffic and prevent unauthorized access to the network, reducing the burden on the central cloud security systems.
So we're adding layers of security throughout the network, making it more resilient to attacks.
That's the idea. It's a more holistic approach to security, recognizing that a single point of failure can bring down the whole system.
Wow, this has been an incredible deep dive. We've covered so much ground, from the basic building blocks of IoT to the complexities of cloud and fog computing, and of course, the ever-present challenge of security.
It's been a fascinating journey, hasn't it?
Yeah,
And we've only just scratched the surface.
right.
The world of IoT is constantly evolving, with new technologies and applications emerging all the time.
It is, it is. I have to say, I'm a bit overwhelmed by all the information, but in a good way. I feel like I've gained a solid understanding of how this technology works, what it can do, and the challenges we need to address.
That's what we were hoping for. Remember, this deep dive was all about equipping you with the knowledge to continue exploring this amazing field. The Internet of Things is transforming the world around us, and understanding how it works is more important than ever.
I'm definitely feeling inspired to learn more, and maybe even try building some of my own IoT projects now that I have a better grasp of the fundamentals.
That's the spirit. Keep asking questions, stay curious, and never stop exploring the possibilities of the connected world.
Thanks for being such a fantastic guide on this journey.
The pleasure was all mine. Happy exploring.